Good afternoon. I hope you are enjoying the sessions at PGConf. Thanks for joining the talk. I am Ramya and I have with me my colleague Shalaka. We are from AWS Professional Services. So topic for today is building scalable APIs, Postgres meets GraphQL. Okay, so as software professionals, right, we all know building product and scaling product is totally two different things, right? When a product is scaling, more users are getting onboarded, new features are being rolled out, right? More and more data is coming up, and application teams would need access to your data. So this is where development team starts to feel the pressure. Like how do you provide the access to your data efficiently, right? So this brings me to my question. How do you usually expose your database to applications in your day-to-day work? Anyone wants to answer? Can you be a bit louder? Okay. Okay. You're talking about the access part. What I'm saying is if your application needs your data, it wants to retrieve your data, how do you provide that bridge? REST APIs, okay. Anything else? Okay, so queries are one of the ways where you can, just fire the query and get the data, right? SQL queries. But queries are inefficient when you are looking at a larger scale. So that's why you need more structured approach, and that's where API comes in. Someone told REST API, right? REST is one of the type of APIs, and API is like a broader term. So anyone wants to tell what is API? If you want to tell. Okay, I'll just continue. API is application programming interface. So basically it is a mechanism by which two software components interact with each other. So there are set protocols and definition, and using which two software components can communicate with each other, right? So just to break it down or make it simpler, let's think like you are in a restaurant. So when you are in a restaurant, you won't go directly to the kitchen and grab the things, right? You place an order. So API, you can think is like a waiter. So you place the order for data to the API. API collects the data, whatever you have requested, and brings it back to you. It's just a structured way to do the stuff, right? So someone mentioned REST, right? So if you are familiar with API and API world, REST is one of the popular APIs you would have come across. So REST is like representational state transfer. So now I would like to tell you a simple flow how REST call usually work, right? So let's say you have a front-end application and then you have a database, right? So what happens is in a simple REST call, let's take an example of a social media app. You need users details. So what REST call does is it makes a call to the endpoint called users. REST usually works on endpoints. So in REST, every resource has an endpoint. Like for example, users is an endpoint in this example. You can have like /posts for social media apps, right? So there is, for every resource, there is an endpoint. So how it does is, then API goes to, collects the details from the database and brings the details back. So usually REST response is a JSON payload. So here you can see an example of user details being returned. So it has all the details, right? Like all the fields, ID, name, email, created at, whatever that user table has, everything is returned. So this is how a simple REST call works, right? But this is at a simple scale. What happens when your application starts scaling? That is our main point, right? Like what happens if there are like more applications coming into picture? So let's look into that scenario. Let's say now instead of one application, you have few more. Let's go ahead with our social media application example only. So maybe you have a mobile app, you have a web app, right? and then there is a database. Now usually what happens, business comes up with requirements, right? Maybe business would ask you, I need all the users details. So as a developer, you would build a REST layer where there is a users endpoint. So users endpoints would give you all the users details, right? Then if let's say business asks you, I need all the posts users made, then usually in a REST flow, how the solution works is you create a new endpoint called users with posts. In the same way, if the business requires like comments, and if there is requirement of analytics, you keep on adding the new endpoint to fulfill those requests of business, right? This is how usually it works. But this, if you see, it's all started with a simple users endpoint, right? Now you have many more, and if the business asks for more requirements or more features, you will keep on adding. So this is where the problem is. If you see the pattern, for every business requirement, you are creating just a new endpoint. It will just go on like this, right? So when you are thinking at a scale, this will also affect your database at the end, because there are redundant queries and database would start feeling the pressure. So this is how the struggle with data access is with REST layer, right? I would want to summarize this challenges, whatever we discussed right now, right? So with REST APIs, there are many popular challenges that we want to point out. First one being overfetching. So what overfetching is? Overfetching is when client is requesting more data than it actually needs. So if you go ahead with our social media example, let's say your request needs email address of the user, username and the email address. So if we compare with our previous example of users endpoint, when you call the users endpoint, it would give you all the details, like all the fields, right? But you only required name and email. But since REST works in such a way that you get all the details, it is overfetching. So now see, overfetching is just a terminology, right? What happens if overfetching actually happens? Like, what is the business impact? You might say, okay, overfetching is happening, what's the impact of that? The impact is very huge because unnecessary data is being transferred. So which means that your bandwidth is being consumed, performance would get affected. In the end, your user would feel your page is getting slower, right? It would impact the user experience. So this is one of the challenge. In the same way, on the flip side, we have underfetching. Underfetching is when client doesn't get all the data in one request. So what happens, like let's say you want all the posts a user made, right? So first you would make a call to users endpoint, okay, get the user ID, and then make a new call to fetch all the data, all the posts of that user. So if you are seeing here, this is not being done in one call, right? You are making multiple calls to fulfill your request. So this is what underfetching is. This will also in the same way results in a slower app performance, because for one particular request you are making multiple calls, right? So these were the two challenges. Then there is multiple endpoints challenge as well, which we already discussed. Like for every feature you are creating a new endpoint. This is also a challenge with REST API, and all of this would in the end result in maintenance overhead. As a developer, you would have to maintain all the endpoints, right? This would also cause scaling issues on a like when you are developing a app of a bigger scale. So these are the challenges with REST APIs, which is most common, and it is not unique to any one company. Any company or organization which is in the scaling phase, right, it would definitely come across these challenges. And one of the most popular social media platform had come across such challenge, and they had come up with a solution in the form of GraphQL. So before I move on, I would like to understand if any one of you have worked with GraphQL before. Maybe you can raise your hand. Okay, I see few hands. Okay, nice. So, okay. So what GraphQL is? GraphQL is a query language for API. So if you look at the pattern with the challenges, most of the challenges surround around the fact that we are getting more data than it is required. Like whatever we are requesting, we are getting more than that, or we are getting less than that. So with GraphQL, it is a query language for APIs that allows the client to get exactly what they need, right? That is one of the main selling points of GraphQL. Then it provides, actually there is a schema which we will come in the next slides. It would give you complete description of the data, which helps API to collect whatever is needed. Also GraphQL is open source. It was open sourced in 2015, and in many of our day-to-day apps, like the apps which we use daily, or the at work or at home, whatever. So those apps, if it is a complex app, it would definitely use GraphQL. So GraphQL is everywhere now. Okay. So we went through the challenges of REST API. Now we will see how GraphQL answers those, right? What are the key benefits of using GraphQL? So first one being precise data fetching. So in REST we saw overfetching and underfetching. In GraphQL there is precise data fetching, like client gets what exactly it asks for. So it would definitely lead to better performance and enhanced user experience, because server load time is controlled, right? And then there is single GraphQL endpoint, meaning REST usually has multiple endpoints, which we already saw, but in GraphQL it is just a single endpoint for everything. So that is one of the key benefits. And third being, since it is answering those two questions, it leads to improved scalability and reduced database load. So these are some of the key benefits. In the presentation, we will see how GraphQL, in depth answers those. So first, we would go through some of the fundamentals of GraphQL, which you need to understand for, to see how this answers our REST API questions. First being GraphQL schema. So GraphQL schema is like a blueprint for API. So if you know database schema, where define data types and other things, it is same. In GraphQL also you have a schema. It defines what kind of data is available, relationship between those data, and how API can access it. So if you see on the right hand side, there is a example for social media app. So there is user type, post type, comment type. So these are the types, and what are the fields for those type. And also if you notice, there is something called query. So query is very important. Here is where you define what kind of queries can API make to the database. So for example, if you see, there is a query for user, right? In the left hand side you can see how it is defined. So you are saying in this query you can query user, and what are the fields it should return? It is saying it should return name, post, and under post it should return title and comments. So this is how you are defining, you are already defining what kind of result you need from the database. And response side you can see, it is giving you all the result, right? Like user, name, post, whatever you have mentioned. So this is how it deals with the underfetching and overfetching problem, because you are already defining what you exactly need, right? And two more fundamentals we would like to talk about. Second being the mutation. So querying is for fetching data, right? Mutation comes into picture when you want to modify the data in the database, basically for CRUD operations, right? So create, update, delete, etc. So here we have an example of create post, where we are defining, we are giving user and title to create the post for the user. So these are like simple examples. Shalaka would delve deep into all those things in her demo. And the last one being resolver. Resolver is like, see, query and mutations don't directly interact with data. Resolvers are like backend functions that can interact with data, like they can execute queries and mutations basically. So this is one of the example for fetching user data resolver. So this is fundamentals of GraphQL. So now I would like to hand over to Shalaka to deep dive into how the technicalities of this GraphQL works. Basically the combination of GraphQL and Postgres, how it can make your API scalable. So yeah, Shalaka.
Thanks, Ramya. So this is the overall GraphQL API architecture that looks like. So let's say like we have 3 to 4 applications that are querying to your GraphQL query. So you will have the GraphQL query that acts as a starting point for your application. And this single GraphQL query will basically interact with your GraphQL server. And in GraphQL server, you get different variations of the server like Apollo, Hasura, PostgreSQL. Based on your use cases, you can use them. So the GraphQL server acts as an orchestrator between your database and the client. So whatever the client needs, as per that request, the server will accumulate the response for you, and it will send the data in the form of JSON payload to your application. Now, as initially we had seen the example of social media application, so let's see how GraphQL and Postgres works hand in hand. So here on the left side, if you see, like you have a client layer for the social media application. So I would just like to ask among the audience, like how many of you posted today something on social media? Over excitement of coming to PG conference? No? Okay, that's very less number. So at your client side, let's say if you want to log into your social media application, you will basically log in through your mobile or web app. And once you log in, what you see is you may see the post of whatever have been posted on that particular day. So at the GraphQL API layer, basically you will be hitting a single endpoint, that is /GraphQL, and within that we will be defining the different operations that we need by our client. So in this case, let's say you want to post something, you want to create, or you want to delete something. So for that you can define the operations, and everything will be performed in a single API endpoint. And then at the database layer, we will be having Postgres, where we will be defining the users, comments, post tables. Along with that, we can also have some additional tables, entities, and relationships between them if we want to make a more complex data structure. So let's dive deep into the demo of how this actually works. So for the demo, I have created a simple social media application where I have used Node.js and React for my front end. And right now I'm just starting my application. So once I start, I see that this is the interface where I can see the previous whatever posts have been updated so far. And let me go and show in the network section of what we see. So let me go in the network tab. So over here, if you can see, like once we log in, we can see the operation that is called, that is the get post, and the API that is called is the /GraphQL, along with the payload that is returned is all the information of whatever are the posts currently in my that are posted on my social media feed. Now let's say if I want to create a new post, so I will just go and click on the create post option, and I will post it. So once I post something, the API that is called, that we see, is the same /GraphQL API, and the operation now that is being called is the create post. So similarly to what we have seen in the get post, we can see that the create post has been called. Now let's see if I want to edit something. So I can again go and click my edit button, and once I click on edit and save it, so this time the operation that is being called is the update post, and the API call that has been made is the /GraphQL. Similarly, for the delete, I am calling the operation delete post, and I am making the same API call. So over here, I would like to explain like whatever the operations that I needed as per my request, whether I want to create a post or I want to update it or I want to fetch whatever the relevant posts are there. So everything is defined in a single endpoint, and only that particular operation is being requested in the backend for my GraphQL. Now let's see in the backend that how we define these things. So as Ramya previously explained, that there are three main components in GraphQL. So first is the schemas. So this is the GraphQL schema. So this is like a structure of your data that you want to define for your user, and this gives you the flexibility of what kind of attributes you want to expose from your database. And from a security standpoint also, defining the schemas gives you the flexibility of access control, as well as you can define the relationships between, let's say, a user who has how many number of posts. So all these relationships you can define within your schemas. The next important component that I want to show is the resolvers. So within the GraphQL, I have defined a resolver. So resolver is a function that acts as an intermediator between your GraphQL frontend and your backend data. So it will process the request and fetch the data from the whatever you have defined in your function and send the response back. So here I have defined the query. So in query I am fetching the post. So query, you can think of anything that is helping you to perform any selection of retrieval of data. That is a select query. So here basically I had defined the get post. So once I log into my application, I should be able to fetch all the posts that are posted so far. So this is where we can define it. And the second one is the mutation. So if you want to perform any write operations on your data, like CRUD operations. So in our case, like we are doing the creation of the post or updation, deletion. So all these things are basically I have defined in my mutation. So mutation is like mutate means to change the data. So that's where we have by the name itself we can identify it. So along with that, in my front end, so whatever applications, operations that I have defined in my GraphQL resolvers, so in my front end section, I'm just passing it to particularly use that operation whenever it is being called, like use mutation of create post, or if I want to perform any updation, and I have defined all my custom queries that I need inside my operations. So overall, this is how we can basically customize as per our needs the operations and handle it efficiently within a single API. Now let's see in the backend what happens is currently we have 3 tables created: user, post, and comments. So whenever any particular post has been made into this from the front end, so we will be logging all that information. So right now in the post table we can see 3 posts. Let me just recreate the initial post that I had done. I love playing and coding, and posted. So as and when the data is post has been made, we can see in the backend this particular has been recorded. So this also allows us a flexibility of real-time data, means we can store it in our database in the Postgres side. So overall, with this demo, I would like to showcase is like we can build a scalable application with the integration of Postgres and GraphQL by defining the number of operations that we need, by handling a single API And there are also some additional features which Postgres gives us that we'll see in the next slides of how Postgres complements GraphQL. So the first thing is like the efficient query execution. So Postgres provides you the query planner that will analyze the GraphQL queries for you, and it will identify which planner suits the best, and it will perform the optimization accordingly. Next is like for your application scaling, as and when your data size increases, the number of applications hitting your data increases. So a single database might be overwhelming to handle your data. So in that case, you can use the Postgres read replicas, where you can redirect your read request and write to your primary Postgres instance. So you can basically define what your calls you want to redirect to using some load balancers. And also you can perform sharding on your data, like in case of some time series data, you can define some key attributes and store your data in your tables accordingly. The last is like the connection pooling. So as and when the API calls are being made, you don't need to recreate every connection newly. So the PG bouncer tool enables you to handle the concurrent queries that you are making to your databases. So basically it will maintain a pool of connections for your database, and it will try to reuse the same connection again if it is made through the same API. So this is how like you can enable optimization at your database level to get a faster query execution, and that will in turn improve your performance at the GraphQL side. So here are some of the real world applications apart from what we have seen previously, like the social media. So one such is the retail example, where let's say in an e-commerce company like Amazon, where you are having a lot of inventory, products, catalog information. So you will have a wide variety of data sets. So you can efficiently manage your data. You can define and have a control on what you want your user to store, user to be exposed. So for that you can use the GraphQL schemas. Then you can also use this for the image sharing platforms, like some of the trending image sharing companies have been using this GraphQL, and they are getting a lot of business gains as well. So along with GraphQL, Postgres will help you to store the image information in your JSON-B data type, which can be helpful to store the image metadata. You can also tag and filter your images, and all this information can be efficiently stored in Postgres. And the last is like the social media application. In order to enhance at the client side, you can perform caching strategies. So you can integrate it with the Redis to do the in-memory caching, and also you can perform rate limiting on the API side to limit whatever are the number of requests that are made to stop the overwhelming response on your server. So here are some of the business gains of GraphQL. So first is like data efficiency and bandwidth saving. So as we have seen previously, with GraphQL you can fetch precise data. This will in turn help you to reduce the payload size. So because of the precise data fetching, it in turn saves your bandwidth and also improves your data efficiency. The next is the development productivity. Like on the developer standpoint of view, since you have a single API to manage, you don't need to create every different single endpoint for every different request. So there is also a reduction in your API development and maintenance. The third is the cost optimization. So overall, if you see, the server cost goes down because you are only requesting to what you need, and also the queries that you are requesting, you can optimize it at your database level, so the cost goes drastically down. And in turn, all these things leads to the higher performance metrics, and also you have a user experience which is loading faster apps within the given time frame. So with that, I would like to conclude by showcasing some of the key takeaways. The first one is that a single endpoint for your API request, then Postgres for your for handling your data scalable databases, along with the GraphQL implementation, because both Postgres and GraphQL scale naturally and they go hand in hand. So this combination provides you a very good scalability for your application. The third is that easily handles the nested data in a single request. So let's say if you want to fetch users that commented these many posts, so you don't have to make separate API calls. Everything will be handled in a form of a nested data structure, and in turn there is less code to maintain. So with that, I would like to conclude that there will always be a question like when to use REST versus when to use GraphQL. So REST, I can say, is you can use it when your application is having a lesser data requirement, means the data is restricted enough and you want to perform simpler CRUD operations, let's say browsing of some catalog data in your website, and there are minimal changes in the APIs that you have to make. But GraphQL comes into picture when you have like an application of medium plus one size, where the database is complex and you need to go through different kind of objects. Let's say in finance, where you have to go through different profiles of catalogs and give the optimal result to your customer. So this is when the GraphQL comes into picture, but there is nothing like black and white. It's also a combination of both REST and Graph that you can use and define an optimal application. So that's what I would like to conclude, and thank you everyone for joining and attending the session. Hope you enjoy the remaining sessions. Thank you.
I just want to know what is one slide. Now one slide further.
Okay.
Further.
Yeah, so just want to know, on PostgreSQL provide a robust foundation. What's that robust phase? That's only.
Okay, so with Postgres, as I had shown previously, we have the different options for managing your connections, where you can use inbuilt Postgres tools like PG Bouncer for managing your API connections. Then with Postgres also you have the flexibility to efficiently manage your queries. You can perform indexing, or you can also store your data according to your application requirement. Like if it is a time series data, in your Postgres you can store it based on a particular time interval. You can partition that data. So this is what we mean by a robust. Yeah. Yeah. So Postgres.
It complements basically. There are features in GraphQL that can complement Postgres.
Because GraphQL is internally querying, if you see, using the SQL queries to query our data. So if those queries are optimized enough, then obviously the result fetching will be faster.
So in one of the slides I saw that Postgres query execution plan optimizes for GraphQL. So I just wanted to clarify, like Postgres doesn't inherently know to parse the GraphQL, right? Like it's the resolver which is doing the transforming and executing the SQL query. So when you mean that the execution plan specifically optimizes for GraphQL, like what do you mean by that?
So GraphQL is just sending the request to your database, like this is the query that it needs to run. And Postgres will internally analyze, like let's say select star from post where ID equal to 1. Now if you have defined an ID as an index in your Postgres database, so at the Postgres level the analyzer will analyze that and it will use that index if you check the query plan for it, it will use it and then it will retrieve the data for you. So basically it's like again how you define your data at the database level. That's where the query planner will come into picture.
Okay, so it's just the SQL query is because
Yeah.
of it's transforming to SQL query. It makes use of that.
Yeah.
I have one more question. So when you showed the demo code in the resolver, the resolver is supposed to query only the columns that are sent from the front end in the GraphQL query, right? But I think I saw that like we are by default fetching all the columns. Like maybe I am mistaken, but is that
Yeah, so basically in my schema, I had defined whatever columns I need to expose. So if you see the post, in my post schema definition, I had given 4 columns. And those columns only, whatever I define in my schema will be exposed through my GraphQL resolver. Additionally, if you want that you only want to expose 1 column from that, so you have the flexibility that in your schema you define only 2 columns, and when you define the resolver, only those 2 columns will be passed.
I can also expose, let's say, 4 columns and query only 2 columns out of it, right? Like that's possible, right, in GraphQL?
So it's like you are predefining what you need. So if, let's say, if you want to expose only the post and ID, so in your schema is where you have that flexibility to define it. If you want to expose only 2, you can define. If you want more columns, you can define it, and you can maybe create another method in your resolver that will fetch the remaining 4 columns. So as per the client request, you need to predefine in your schemas.
Oh, so it's not dynamic based on the query from GraphQL from the front end?
No, so it's like what request you make, so that request is being tagged to the action that is being performed in your resolver, and accordingly you will fetch that information only. It's not like randomly we give all the information at once, and so that's where you can.
Okay, thank you.
Here you mentioned like a single endpoint, right? You are achieving that through passing the query parameters, right?
Yeah.
This one we can do in simple REST also, right? We can define one single endpoint and we can pass whatever operation we want to do through query parameters, right? It's no difference.
But you would have to use query parameters, right? So
here also you are using the same thing, right? If in your example you are passing the operation, right? Which operation to do?
But it is ease of like convenience, right? Like for complex, like simple applications, query parameters you can use. That is okay. But that is also one thing is like you are exposing those things in your call itself. This is more restricted way in the functions way.
But the same thing you are doing here also, right? Can you go back to your last example where you are showing that input header, request header? You are showing that example, right? When you call the network tab. You're also exposing the method name, right? The same thing you can do in REST also, right?
So over here, if we see the endpoint that is called, our main point is the endpoint. So in the REST API, like if you want to perform updation and again you want to perform the post operation. So you will have resources defined, and in that you will have to create two different endpoints. So we are not saying like it's not possible. It is possible, but the complexity increases as your API calls will increase. You will have to define that many number of endpoints, and that's how this will be more flexible for your use case.
And one more thing, so let's say when we release a new endpoint, so that time we have to go through all the endpoint testing, because when you use a single endpoint, right, we have to retest everything, right? Normally when you do with the rest, I'm saying simple fast API call, so when we have a different endpoint name, right, so that time when we do a release, we'll be testing only that particular endpoint. In your case, let's say if I'm adding one more endpoint to the 100 already, let's say I have 100 one, so I have to retest everything, right, to see the impact.
No, actually the endpoint is same, but you are just adding, think of it as one additional function. So you just need to test that particular function. Let's say I add the delete function in my application. So today you will just click on the delete button and see whether internally in the network that is being called. That's how you can test it. Thank you.
So we'll, it's already 1 o'clock, only last question.
Okay.
My question is, how is GraphQL different from Postgres? Because here I have to define the schema, the query, the mutation myself. But with Postgres, it automatically analyzes my schema, the DB schema. It understands the foreign key relationships, and I can selectively choose what I want. I mean, the same way. And it's a much thinner layer, which much lesser work.
Yeah, I can take that up. So Postgres is a database, right? GraphQL is an API. So how do you expose database?
No, I am saying PostgREST. Post-G-R-E-S-T.
Okay, Postgres.
With that, we are not quite familiar with, we have not used that.
Maybe you can take it up offline.
Yeah.
Okay, one last thing. The thing that the person there mentioned, that if the schema has 4 keys and I want to only access one in the front end, you are saying essentially I need to define one more query, so to speak, or I cannot say dynamically that I want to only access this key. Is that the case? What you said there? If that is the case, then how is it different than having a different REST API? Like if I can't selectively tell at runtime, or that I want to only access this specific key, like how does that solve the original problem?
So going with REST API, like see, if you want only one particular, so the thing is in this case, you should be familiar with what is your requirement. Like suppose you have a particular team who is only interested in these many fields. So that fields you can define initially. Whereas with REST API, if you have one particular API already made that is fetching all your database attributes. Now this another analytics team comes up who is only interested in, let's say 2-3 attributes, whatever. So you know that even in REST you have the same requirement, but here then what you will do, you will create a new endpoint for it. But in case of GraphQL, you have the flexibility that within the same endpoint you can just additionally you can define one more operation that can be handled and they can use it for their consumption.
So this comes back to the thing that guy said. You are just saying that there will be not an additional endpoint, but a separate piece of code still needs to be written. There's just an abstraction, right? I still have the same endpoint you are saying, but I will write extra piece of code. Otherwise, with the RESTful principles, I would have to create a separate endpoint.
Yeah.
But there also I will be writing the same piece of code, just maybe some boilerplate here and there. So other than the abstraction, it seems like it does exactly what...
Yeah, so to your point, I can say that actually GraphQL is nothing but internally it is also built on top of a REST API only. Like internally also it is using the post method of REST, where you can think it as an abstraction, and not all the use cases where you feel like GraphQL you should use. Because for simple use cases, using REST will be more, makes more sense, and also starting an application with REST is anytime a good choice. As and when your application scales and you have a bigger data set, you have a varying requirement, let's say a mobile application where every page is different and you want to give a different experience, that's when you can use the GraphQL. So it's a medium plus size.
I mean, modular approach is always better for scaling applications, right? And with GraphQL, modular approach becomes easier.
Thank you so much, Shalaka and Ramya. It was a wonderful explanation.